Hydraulic fluid as a lubricant allows this block to glide with less friction and wear on the parts. In our example of heat transfer medium, the heated fluid enters and radiates its energy out and leaves the system cooler. In our example of energy transfer, hydraulic fluid will transfer energy from the input side to the output side because fluid is basically non-compressible. In our example of sealant, the hydraulic fluid between the wall and the piston will act as a sealant because of its viscosity. Hydraulic fluid is basically non-compressible and can take the shape of any container. Because of this, it exhibits a certain advantage in the transmission of force. These are examples where the fluid will take the shape of a container. Using a positive displacement pump, we transmit energy from the prime mover, our input source, to the actuator, our output, through the medium of a non-compressible fluid. As the fluid passes through the conductors and components, certain considerations must be given to ensure maximum efficiency of energy transfer. These considerations include the understanding and proper application of fluid velocity and viscosity. You have completed this training section. Velocity is the distance a fluid travels per unit of time. With a fixed volume of fluid going through a conductor, the velocity of the fluid will depend upon the inside diameter of the conductor. If the diameter of a conductor is increased, the velocity of the fluid will decrease. Conversely, if the diameter of the conductor is decreased, the fluid's velocity will increase. To better illustrate this principle, we have two simple systems in which two pumps of equal displacement of 30 gallons per minute move fluid through conductors of different sizes. The displacement remains equal, while the velocity of the fluid varies with the size of the conductor. The fluid turning flywheel 2 is moving 4 times faster than the fluid turning flywheel 1 because the inside diameter of the pipe for flywheel 1 is twice the size of the inside diameter of flywheel 2. However, the flywheels turn at the same rate because the volume displacement is equal in both systems. Viscosity is a measure of a liquid's resistance to flow. A thicker fluid has more resistance to flow and a higher viscosity. Viscosity is affected by temperature. As a hydraulic fluid's temperature increases, its viscosity or resistance to flow decreases. A viscosimeter, the device used to measure a liquid's viscosity, consists of a small reservoir surrounded by a water bath used to heat and maintain the liquid at a constant temperature. There is a small orifice below the reservoir through which the liquid can pass once it is heated to a specified temperature. A stopwatch is used to determine how much time it takes to fill a 60 millimeter flask. The number of seconds that it takes to fill the flask at a given temperature is the liquid's viscosity at that temperature. As illustrated, the fluid on the right has a lower viscosity number than the fluid on the left.